Principal, Honorable Speaker, sir. So now we are going to start our technical session 2. So today we have with us our Honorable Speaker, Professor Sunit Kr Sen. So may I take the pleasure to introduce our Honorable Speaker, Professor Sunit Kr Sen, with all of you. So Professor Sen was the professor for the Department of Applied Physics, University of Calcutta. He has completed his BSc Honours in Physics from St. Xavier's College, Kolkata in the year of 1972. Dr. Sen has completed his BTech and MTech for University of Calcutta in the year of 1975 and 1977 respectively, and PhD from the same university in the year of 1993. He was assistant manager in Bokaro Steel Plant during the period 1978 to 1983. In 1984, he joined the Department of Applied Physics as a lecturer. He is a member of IEEE and IETE. He was head of the department and also USIC for the University of Calcutta from the year of 2008 to 2010. Dr. Sen has industrial experience of more than 5 years with Bokaro Steel Plant, India, in the areas of maintenance, procurement, design of electronic instruments, etc. He has worked with block pulse functions and Walsh function, their characteristics and their applications in the field of communications. Now his area of working is the new design of PRBS generators, new designs and developments of various types of ADCs like pipeline ADCs, Sigma Delta ADC, their shortcomings and possible improvements. Sir, on behalf of Department of Applied Electronics and Instrumentation Engineering, Guru Nanak Institute of Technology, we heartily welcome you as the resource person of our AICTE AQIS STTP program phase 2. Sir, we are honored to have you with us as a resource person. So now I would like to request our coordinator, ma'am, Mrs. Bapita Roy, to felicitate our speaker with the flower bouquet. Ma'am, please give me 1 minute time to share my screen.
Sir, welcome to this phase 2 HTTP program, and thank you on behalf of Department of Electronics and Instrumentation Engineering that we are having you with us in this phase 2. So, sir, I basically made you the co-host, and this is the small token of appreciation and respect from my department as well as my college. So please accept this one.
Thank you, HOD sir. Thank you, Dr. Banerjee. So, can I start then?
Yes, sir.
Okay, welcome participants to the AICTE approved STTP on your green IoT. This is the second lecture of mine in which just a minute I am yes, is it okay? Is it okay then?
Yes, sir, it is okay.
Okay, so the one on which I will
Sir, your voice is not properly.
Now is it okay?
It is okay. It is okay now.
So today's topic of discussion is wireless sensor networks or WSNs. Uh, uh, this is having a huge relevance as far as your IoT is concerned, because IoT, geographically, a particular IoT network, it spans over a huge area. and maybe that in certain inhospitable
Sir,
terrain.
sorry to interrupt, sir. I think some if you set your microphone properly, I
Yes.
think now it is okay. But whenever you have started, the your sound is going low a little
Okay.
bit.
Now is it okay now?
It is okay, sir. Now,
Okay.
now it
Okay.
is okay.
So, I mean, this WSNs or wireless sensor networks, it's having a huge relevance as far as your IoT is concerned. IoT is applied. I mean, in my first lecture, I mean, huge discussions on your IoT and its applications in varied areas. And suppose that some inhospitable, terrains are there in which it's very hard to reach places, and in which wired connections is just an impossibility. So that we cannot have your wired connections like the connections that we have in our houses or like that. So that in those particular cases, if we are to take certain measurements like that, in those particular cases, the sensors are placed. Those particular sensors are very very power starved, and the networking amongst these particular sensors, they will have to be your wireless in nature, and that gave the fillip to the development of these wireless sensor networks as far as IoT is concerned. So research on WSNs, it started around say 1980s, but it got a huge fillip at around say 2001, when researchers started applying these sensors in your in the field of industries. So WSNs plays a major part in IoT, and the particular sensors which are your applied in WSNs or wireless sensor network technology, they will have to be your very small. They are rugged, they are inexpensive, and they are very very low power devices. One thing I want to make it very crystal clear to you is that because the sensors which are there, which are connected in a wireless fashion to make the network, they are being, say, suppose they are battery powered, and the particular places in which the sensors you're placed, they are very hard to reach places. So that if these particular sensors, when measurements are taking place, if they are consuming a huge amount of power, the battery will drain out very very fast, and very very recurrently these batteries are to be they are to be replaced. Consequences are the batteries are to be replaced by human beings, and those particular places, they are very very not negotiable nicely. So that in wireless sensor networks, the maximum importance is being given that the sensors, they must be very very their power consumption must be very very low, and each sensor, now with regard to the sensor, I have a talk like this. Each sensor acts as a node in a WSN. Each and every of the sensors, they are acting as a node. And what is a WSN? It's a network of nodes. So now, as days are passing by, we are having your advances in computing and communications. They are your, slicing like anything. And also another technology, which is MEMS, micro electromechanical systems. This particular technology, because of its very, very low, very ultra low power consumptions. Uh, these sensors, which these are based on your MEMS technology, and they consume very, very small power. So, researches are tend to be, driven into the MEMS directions nowadays. The new research in WSN focuses on networking technology. That means the sensors, how they are being networked. And then after networking is complete, the network information processing and the flow of informations, that is to be guaranteed. Now, a network versus individual sensors. Suppose that individual sensors, they are there and they are not networked. And in the second case, the sensors, they have been networked to form a particular group. And huge advantage we derive by connecting the sensors in a particular network. What are those? These are the, I mean, there are, four, ones, which are the major advantages of networking of these particular wireless sensors. The first is extended range of sensing. That means it covers a very wide area of operation. I mean, in a short while, I will show to you that this from the sensors to the your base stations. These particular connections can be yours in a single hop or in multi-hop fashions. So that extended range of sensing, it can be your arrived at by having your multi-hop communications from the sensors themselves to the your ultimate your destination or the sync point. Redundancy, multiple nodes are very close to each other, so that they will be having, their outputs, they will be matching very much with each other, so that it increases the fault tolerance of the system and improved accuracy. The sensor nodes, they collaborate with each other, they combine their data, and that gives rise to an increase in accuracy of the sense data and extended functionality. The sensor nodes, they not only perform the this sensing functionality, but along with that, they forward their output data, ongoing data to the sync to the sync, and these are the typical wireless sensor networks. So, this particular one, this is a sensor feed in which the sensor nodes are your placed, and a particular sensor node, how it is going to the sync. This is the particular one which is a sync, and in it, you see, it is traversing its path like this, traversing its path like this. These are the arrowheads in a bidirectional fashion, so that in this particular way, it's now traveling towards the sync. This is, as it is shown in the figure, this is a multi-hop communication to the sync. From the sync, it can be, key and gateway of the system. And from that one, it is your, delivered or uploaded to the internet. And then the task manager is there. And then the user, you and me are there to get the sense data. And this is another way of putting the same thing. This is the sensor network, sensor node networks. These five ones are shown. They are your communicating with each other and sense data. Ultimately, this is being forwarded to the gateway. From the gateway, it is being taken to the internet, and from the internet to the users, users A and user B, and as it is shown in the figure now. Now, when we communicate in a wireless fashion, so that there should be some standard, so that so many sensors are there, and in the vicinity of the particular place in which you are working, maybe that certain other persons are also having their sensor networks. That means two sensor networks are there, which are operating in the vicinity of or close proximity of each other. That is why that gave rise to your wireless standards. Those wireless standard protocols are to be maintained for proper acceptance of data at the same place. So some of the standards that which are your which have been accepted as standards and applicable in your wireless communication systems. They are like this. IEEE 802.11, 802.15, and 802.16. And also that these particular three standards that have been shown, they are having so many subdivisions within them. Now, brief, details about some of the wireless standards which are being applied in your WSN's technology. Wi-Fi or wireless fidelity, it's a LAN technology based on this first one, IEEE 802.11 specifications, and this is also called your wireless Ethernet. And the next one that follows is WiMAX. WiMAX is standing for Worldwide Interoperability for Microwave Access. It's based on IEEE 802.16. It's a family of wireless broadband communication standards, and it provides multiple physical layers and MAC options that is there. And WiMAX is better than your Wi-Fi in sensor networking applications because of its better coverage and cell capacity. A cell is a particular area in which the sensor nodes are placed. So WiMAX is a full duplex technology. That means transmission is both ways. It's possible at around the same time. So data transmission and request grant mechanisms are allowed, and it uses separate channels for inbound and outbound transmissions. So inbound transmissions from the from the same side towards the sensor, that is your inbound, and from the sensor to the gateway, it is your outbound transmissions. So separate channels are earmarked for this duplex transmission mode in WiMAX to be realized. So another technology which you are knowing is this is your Bluetooth or Bluetooth low energy, which is also there, which has been introduced into the market. Of late, Bluetooth uses IEEE 802.15.1, and it's a channel hopping scheme which ensures low latency. That means time gap between the acceptance of the data by the sensor and its ultimate flow or your ultimate whatever the way that you want to put it. It's reaching the sync in a very fast manner. That means it gives rise to a low latency, and it's having a high throughput. That is another major advantage of having your Bluetooth. The hopping frequency is 1500 hops per second. Acha. That it reduces chances of interference and fading. Becomes a minimum. It uses TDMA technology. That means time division duplex, time division multiple access scheme for transmission of data and message. And separate hops are used for to and fro communications. As in the previous technology also, WiMAX, it is also using separate channels for on transmissions and transmission towards your sensor. But one flip side of this is it does not guarantee end-to-end communication delay, although it's having a low latency. Acha, it uses a half duplex method for transmission of data. Acha, this is as far as your Bluetooth is concerned. Another is your low the energy is standard. It is your Zigbee, which like your Bluetooth, it uses PN, personal area network technology, and power associated with Zigbee is ultra low. It's very low, and it is because the output power associated with Zigbee, it is very low, so that it is used in industrial monitoring and control, in which your domain of this thing control will not be very widespread. In a very small area, this monitoring and control is affected in an industrial scenario. So it is based on 802.15.4 physical and MAC layers. This is very low power, very low cost, and low data rate. That is a negative side of this one. It is a low data rate communication protocol. The Zigbee, like your Bluetooth, it also does not guarantee your end-to-end communication delay. And in Bluetooth, it is the technology TDMA, whereas in this particular case, it is the technology that which is used. It is your DSSS, that is direct sequence spread spectrum technology for transmission of information. Zigbee does not guarantee reliability against interference and obstacles. So, if obstacles are there along the path in which your communication is taking place, in that particular case, Zigbee does not guarantee the reliability in your communications. Because why it is so? Because it is its energy associated with Zigbee, it is very low. It is ultra low. That is why it cannot guarantee reliability in your communications when some kind of obstructions or interference is there along the path along which this communication is taking place. And this what, and here it is your ISA 100.11a. These two technologies are mostly used in field bus systems. These are your wireless technologies. I mean, 10 to 15 years old technologies which are there. What it is standing for? Uh, Wireless highway addressable remote transducer. It is depending on IEEE 802.15.4 standard like ISA 100.11a also. So one positive point of using your WHA or what technology is that it is backward compatible. That means in particular places in industries where hard devices have been placed, yeah, these hard devices, this is your wired connections. But to that one, if I mean technological advances are made and these hard devices are being put into the in the this or what, because of the particular advantage that we have in using your what, which is your backward compatible, so that the existing hard devices can be in service when what is introduced into the existing hard devices. It uses the 2.4 gigahertz ISM, industrial, scientific, and medical unlicensed frequency band for communications, which I am coming in a few slides down the line. This is a first open standard protocol for WSNs in the field of automation and control. As I have told you, this what and the ISM, this particular one, they are used in automations and control in industries. And you see, in the, like your ISA, this one, what it also uses your TDMA, time division multiple access technology, and it has 250 kilobits per second of data rate. It supports channel hopping with a 5 megahertz separation between two any adjacent channels, and it's also having certain other advantages: frequency diversity, path diversity, and proper message delivery methods ensure high reliability. Message along its route to the destination, it can be your from it can be your affected by your data poachers, so that message protection along the route of your data traveling, it should be your ensured, and this is ensured by using a 128 AES algorithm. This AES stands for Advanced Encryption Standard. So that what AES does is it converts a plain text to your cipher text uh, with your haphazard your characters of 128 bits total, so that even if the data poachers can have a hand to this one, they can reach to the communication which is taking place from the sensors to the your sync. They cannot decipher of what is their actually raw data. They cannot get into that one. They cannot extract the raw data from that one because it is encrypted like this. Now, starting with your coming to your ISA 100.11.8, one negative point as far as your what is concerned, it is not backward compatible. It also uses your 2.4 gigahertz ISM band. This particular ISM band, this is your unlicensed, so that you need not have to pay anything for using this one. Uh, but one thing is that the amount of power that you can inject into your this communication, that it is your limited. That is governed by laws. Acha. This is a low cost, less complexity, and low power consumption, and robustness to your RF interferences are there. It operates in star and mist topology. As already told that it operates in your this mode of operation is your TDMA. Because of TDMA mode of operation, like your what, it can ensure your sleeping routers. That means routers which are presently not your working, they can be made to sleep, so that power consumption can be your uh, made to a minimum. Message protection, as in your what also, it uses a 128 AES algorithm. So now, this in the last one, I talked about your ISN, which stands for your this industrial, scientific, and medical band. It's a wireless sensor networks. They use this license-free or unlicensed ISM band for error-free communication. This ISM is an unlicensed band which are having your three ranges in which they can be used. These are the standard ones, which are the unlicensed or license free band that are used in your medical field or your technology or industrial fields like this. And one, drawback of this one, because when, as I already told you, when two or more wireless devices they operate in the vicinity of each other in the same band, they are operating in the same band. Suppose this is the first band, this is the second band, this is the third band. Say if they are operating the 902 to 928 megahertz band in the same band in the vicinity of each other, two wireless devices sensors they are operating, in that particular case, electromagnetic radiation from one sensor, when it is transmitting, it can affect the operation of the other. That is why I commented a bit earlier that the power associated with while it is data in encrypted fashion, which is when it is your transmitted to the same site, the power associated with that one should be restricted, should be very low, so that electromagnetic radiations from these ones, they if even if they affect, they will affect in a very low fashion, because their powers injected into them, that is very moderate. Now, widespread use of wireless networks are increasingly being used nowadays. As the days are passing by, wireless networks are gaining in importance, and wireless computer networks using LANs, Bluetooth, and near field devices, NFCs like that, and cordless phones, they are being used. This is the license-free or unlicensed frequency bands. These four words are there, out of which three have been shown in previous slide. And these are the different frequency bands. They have different output powers, bandwidths, and duty cycles also associated with them. Now, WSN technology or wireless sensor network technology is applied in smart homes, very big houses, complexes like that, smart grids, smart water, and intelligent transportation systems and whatnot. In every and possible situations, WSNs can be applied. Now, one very basic issue, it is your ownership and use of data. Now, data brokers means the particular ones who deal with your data. Suppose you are generating the data, it is the data brokers who handle the data on your behalf. Now, we are having a flights in trade and business by pulling your data from the different nodes. Maybe from my industry, maybe from certain other industries like this. That is the job of the data brokers. The issue is the one which is the legal one, so that some legal issues involved in this. Uh, Hello, uh, a machine that notifies the legal. Suppose a machine it is there, it is used by the user of the machine in a particular fashion, which is prohibited by law. If that particular machine which is being used uh, by the present owner of the machine in a particular fashion which is not permitted by the present owner, then the machine automatically informs the actual ones that that particular machine has been illegally used, and that means it has been used against the law. Suppose one example is plane crash. You are obviously knowing that in each and other planes they carry a black box. In the case of any disaster or eventuality that's occurring, a plane crash is occurring. Then by retrieving the black box, and after proper diagnosis of this black box, where the fault is lying, whether some mechanical or electrical fault with the plane has taken place, which is the responsible for its crash, or some errors that which has happened on behalf of the pilot. It can, identify which has been the cause of the this plane crash. So liability of the owner of the plane or the operator, that means pilot, it comes to the fore or it comes into the forefront. Now this is a term which is called a moat. What now a moat is? A moat is a small, it's very low cost and low power computer. So what does it do? This is the block schematic basic building blocks of a moat. A moat is having a microcontroller. The main thing is it's having a microcontroller on the right. Say this is a sensor one, this is the sensor two, and by means of obviously the sensors output, they are your analog in fashion. They are your digitized by means of the ADCs, so that they are being fed to the microcontrollers. Then trans-receivers are there. This is the external memory. So from the trans-receivers, this is being transmitted to the outside world, to the sync site, and from the sync site, it is being taken into the microcontroller again for controlling purpose. So it can monitor a particular mode. It can monitor one or more sensors. It's a sensing device that is capable of performing physical sensing. Physically, it senses like your temperatures, pressures, etc. Gather the sensory informations, and it can compute also because of the presence of this microcontroller and the memories that are there in this. Now, usually it is also able to communicate via the trans receivers. This particular block, it is standing for your trans receiver, so that it is able to communicate with the, outside world with other connected sensor modes. The last point about the mode is a mode is always a node, but a node may not always be, is not always a mode. That means a mode will have to be a node, but a node may not be, it may be or it may not be a mode also. Now, the sensor nodes, some brief idea about the sensor nodes. These are your resource constants. That means they are very, very low power devices and they are very small in sizes. Mostly they are your made of your MEMS technologies. And sensor nodes are, they are your, the sensors are used in these particular, places, out of many other applications that it has. And lastly, a sensing node, it is consisting of these four units. One is your sensing unit, a processing unit, a communication unit or transceiver, and a power unit. See, the sensing unit, it senses the physical conditions, say temperature, etc., and converts it to the digital one. The processing unit, it accepts the data and then it forwards it and manages your radio communications by following some network protocols. By software controller, that which is residing into these memories and the microcontrollers, this particular unit, the processing unit, it manages to minimize power consumptions in radio subsystems and signal conditioning and communications. It is pre-programmed to perform the tasks which are being assigned with. Performance of the processing unit, it is your evaluated on the basis of what the data rate of sending the data to the sync site, or the processing speed and the memory capacity and the peripherals. The communication unit consists of a common trans-receivers. That means it can transmit, it can receive also, which connects the node to the network. It is mainly used to transmit and receive data information among the various nodes and the sync station and vice versa. Mainly, there are four states in a communication unit. It is, these four states are your transmit, receive, then idle, and the sleep. Now, wireless sensor networks, these are infrastructure less power constraint. These are maybe I was stressing upon this particular point that is wireless sensor network or WSN, it is very, very power constraint. The less the power that you consume, the better it is for the wireless sensor network. Acha. These see these basic building blocks of a sensor node. This is having the sensing unit, processing unit, the communication unit, that means the transceiver, and then it is sending the output signals, the data in a wireless fashion. And these three units, they are being tied to the power unit. So power is drawn from rechargeable batteries or solar power, which is a better option in certain places where very bad places where access to human beings are very restricted. In those particular cases, it is advisable and it is actually used. The solar power is used instead of your rechargeable batteries. And a sensor node, it performs data acquisition, processing unit, it performs your analysis, aggregation, compression, and fusion tasks. And the miniaturization technology of WSN sensors, it is based, as I have already told you, it is the MEMS technology that which is used for the very minute, minuscule sensors which are used in WSN technology. Uh, a sensor network, contains the remote sensors, then your transceivers and the final processing nodes. The sensors are connected in a single hop or multi-hop manner. As I have told you, if this WSN or the wireless sensor network, it's physically or geographically, if it is small in size, then a single hop. That means from the source to destination, it's a single hop. The data can be deposited, can be transmitted to the sink in a single hop. That is called a single hop. So by virtue of a network being a single hop one, it tacitly implies that the particular network, it is geographically small in size. And when it is your multi-hop in manner, that means it is widespread. That is why multi-hop fashion, that means it is equivalent to your hop and jump. So that in multi-hop fashion, from the sensors, that means from the sensors means from the source in a multi-hop fashion, ultimately to the same side, it is your delivered not in one go, but in multi-go. That means multi-hop fashion. And this whole combination of this multi-hop in which so many sensors are there, maybe or thousand or uh, hundreds or thousands of sensors are there, that is called a sensor field. That means the sensor field is the one in which I already saw to you in a previous slide, that particular figure. The sensors are placed in a certain particular place, encompassing all those particular sensors, that is called a sensor field. Acha. It operates reliably in both the location of sensors. WSN, that it will operate reliability is so much of importance that a WSN sensor, whether it is operating reliably or not, it depends on the location of sensors as also their time stampings, whether they have been done properly or not. The nodes communicate with the sync, and GPS technology is also used for location of sensors in the correct fashion. The nodes collect the data, analyze the data, compress the data, so that the amount of data that which is to be sent, which is to be transmitted, that number of bits or bytes, that is it is your minimized, and then it is forwarded or routed to the sink. Because I want to tell you one particular point is that because so many the things are operating within the sensors and which consume the battery power, the most the battery power is consumed when the data it is being transmitted compared to other functions which are being carried out into that particular node or a sensor node. So that repeating the second time, when we are transmitting certain data to the sink, it consumes the maximum power. So that data collected from the nodes, if they are your analyzed, the redundant data is your rejected, the available data is your compressed, so that it is compressed to the extent that it is minimized, extensively, so that amount of data, number of bits that which are to be sent, they are your minimized very much, so that that is now being sent to the same site. And the advantage is that because you are sending, I mean, less number of bits, and also that because this sending of data in communication, it consumes, it absorbs the maximum amount of power. So the less the number of bits to be sent, the better for the system. The, I mean, more is the longevity of the batteries that which are associated with each sensor. Now, data that which is your collected at the base station or the final processing node, uh, and hence nodes closer to the base stations will have more data burden. Why it is so? So suppose, I mean, some data which are far a, I mean, maximum distance from the sink. Those data by one half it is being delivered to the, I mean, succeeding your node. That particular node it is also having its own data. To that one, the added is the one from the far place, from the first one. So that the second layer it is your by virtue of its accepting the uh, data from the first node outer periphery and its own data, so that it's having your more burden. And I mean, particular nodes which are your I mean placed at the third layer, their burdens are increasing. So that as we are proceeding towards your same site, the particular nodes they will be having more data burden to handle. Now you say this maybe that you can explain the situation that which I have just now you explained. This RS it is standing for the remote sensor. These are your by a single hop. This is connected to this particular I mean remote station. So that this particular remote station is having the data burden of this particular remote station and this particular remote station. So that this particular remote station this is having the data burden of itself and these two taken together, so that this is being taken to this particular RS, so that this data that which is coming and being delivered to this particular RS, it is in a multi-hop. This is a single hop, and this is another hop, and more than one hop that it is a multi-hop. So and now it is your this RS from this to this one, and to these combinations of all this data that is being delivered and put into this particular one, which is called your CN, or this is called a clustering node. Likewise, these particular ones also, these are the single hops as it is written over the diagram also. These are the single hops. These are the single hops also. There is a CN that is placed over here. There is a CN that is also placed over here, because this CN is taking care of these particular nodes. This CN is taking care of these particular nodes. But mind you, this particular CN on the cluster node, it is taking more burden compared to this particular CN or the clustering node, because this CN is taking the burden of these three ones. But this particular cluster node, which is more towards the same side, it is bearing a load of these three RS and these two RS. That means a total of five remote sensors data burden. It is being carried, and it is being loaded with the data burden of five remote sensors. And now it is your put finally to the final processing node from this one, and from this one. This is that's a typical network sensor, and it meant how the sensors they are placed physically, and then how the networking of the sensors are done, and the data from each and every of the sensors, how they are being sent one after other in a multi-hop fashion to the same site. This is an replica. This particular figure is a replica of that particular one. This is another figure of the one that I have shown to you. In the earlier slide. See this one. This is a, this particular one. This is the cluster rate. That means this is a cluster rate. This is a cluster rate. This is a cluster rate. And these are the as if these are the your remote sensors. These are the remote sensors. These are the remote sensors. These four are the remote sensors. So that there are, see, there are three clusters. This is a cluster, this is a cluster, and this is a cluster. These clusters, this or clustering node, it is taking the data burden of these three nodes and the data burden of these three nodes taken together. So this cluster, it is, I mean, absorbing the data of six, I mean, RS or remote sensors that I have shown to you in the previous slide. So from this one, it is going to the base station. From this one, it is going to the base station, that which we can term as the sink. Why it's not progressing?
Hello, sir.
Hello,
Hello.
hello.
Yes, sir.
It is not progressing.
Uh,
It has got stuck up. Shall I? I mean,
okay.
shall
Sir,
I? I mean,
you just then off your screen, then again screen share. If
okay,
it
okay.
is
Then I am stop sharing, and then
okay.
I will re-enter. Okay.
Okay, okay,
Wait.
sir. Okay, sir.
Be there.
Okay, sir.
Sir, actually the weather outside is very bad. Actually, I think that is the reason that network may be fluctuating.
And that is why you will have to, I mean, fall back upon your wireless sensor networking.
Yes, sir.
Yes, sir.
Okay. So you will have to study this particular one, how to improve, because of the, yes, this weather, that it is a particular topic is there, which I'll be, I mean, coming in a few minutes time. I mean, this wireless, this sensors of the wireless sensor networks. This is having a huge, this environmental ones, like your temperatures, then fog, and like those. They are having a huge bearing on the efficacy or the reliability of these wireless sensor networks, which I will come in a few minutes time. Okay, be there. And so up till now, it was your complaint. So now features of a wireless sensor network. The wireless sensor network, it should be scalable. That means it is a wireless sensors, your efficiency. It is independent of the number of nodes that which it is handling. Suppose that at any particular instant of time, it is, I mean, working with say, a certain number of sensors, which is 500. So because of certain exigencies of the situation that which has arisen, some 100 sensors have to be added. So that now instead of 500, it has become all on a sudden, because of the, I mean, necessity. The number of sensors, it has shot up to your 600. So that by the term scalable, it means the efficiency that which our this wireless sensor network, it was operating with 500 sensors. The same efficiency it will work with 600 sensors. Although there is a add up of your quite a huge number of sensors have been, I mean, drastically added to it all on a sudden, 100 numbers out of 500. So that efficiency of a wireless sensor network, if it does not degrade itself with the change of your number of sensors, then it is called your scalable. It uses the unlicensed ISM band, which for data transmission purpose, so that you need not have to pay any kind of fee for using this unlicensed ISM band. It's an ad hoc network that organizes itself into an infrastructure-less network. Now, certain topologies of such a network, they vary frequently, and it also depends on how the sensors in the WSS they are your placed. So that it can be your peer-to-peer type, or maybe your hop type. And another thing is that some of the nodes, because of the necessities, they are your densely populated, or in certain other places, the sensor nodes, they are thinly populated. Acha. the one particular point, one feature associated with the nodes are they are very power constraint, which I am stressing upon. Quite a few number of times already. These sensor nodes, they are self-configuring in nature. They can configure by themselves, and they are robust to topology changes. That means, as just now I have told you, instead of your 500 numbers of sensors, we have added another 100 numbers, so that it has become now your 600 numbers. In spite of that one, certain topological changes have been done. Even after that one, if the WSN should be robust to any kind of changes that is being affected to a particular network. Maybe some additions or deletion of certain sensor networks, it will not change as far as your robustness is concerned of the network. Now, data from several groups of nodes are clustered and hence fewer transmissions are needed. Now, challenges in a wireless sensor network. This is again, this particular term is coming up. It is very power constrained. Hence, communication protocols for such a network must have very high power efficiency. So that a comparison obviously comes in. The such protocols for WSNs mainly focus on power consumption and efficiency, unlike its traditional counterpart. That means word one, with which we are more accustomed. They are mostly concerned with your throughput. That means and the number of bits that can be sent to the sink per second. That is a measure of throughput. And delay, that means your latency. So that as far as your wide networks are concerned, we are, mostly focusing ourselves on your throughput, amount of number or the number of bits that can be sent per second, and delay, that means your latency. Because WSN sensors are very much power starved, they are very power constrained, so that more stress is placed on your power consumptions and the efficiencies associated with that one. Acha. Then node deployment in WSNs is another key area on which protocol development largely depends. Acha. Then random deployment of sensor nodes needs the development of protocols which must be self-organizing, so that the protocols should be such that the nodes should be self-organizing in nature. Such particular nodes should collaborate with other nodes and can adapt to failures without any human interaction or intervention. In the majority of cases, the nodes deployed in WSNs, they are left unattended. See, mind you, these are your left unattended. Does it mean that the nodes, they work the particular sensors, they work day in and day out. They don't, go out of order. Yes, they will, obviously. But even if, but they are left unattended, and even if certain, one or two, sensors, they become your dead. They are not, responsive to either. They cannot transmit. They cannot even accept any kind of data. They have become dead because of certain, exigencies. Then the repair, maintenance, and anything, adaptation to the new environment should be inherent to them, so that it is self-adaptive in nature. The WSN. It should be seen that such self-managed features of sensor nodes must be designed and implemented in such a way that they operate over a considerable length of time with limited power resources. See the limited power resources, this particular term, it is again coming up. It is coming up again and again because so much of stress is your importance is given to your power limitations in your WSN scenario. Ambient energy harvesting. Because the nodes are your very power constraint. That is why if the sensors they can be your powered by your ambient energy by harvesting the ambient energy, then it will be far better. So some of the technologies which are used for ambient energy harnessing, they are your miniature piezoelectric crystals micro oscillators, thermoelectric power generation elements, or electromagnetic wave reception devices. One example is shown over here, very simple example. If you knock the desk with your fingers at a certain particular rate, then it will support a censored node sending 2 kilobytes of data 100 meters away. I mean, 100 meters is quite, long away, and this is your 2 kilobytes of data. It's, quite a lot of data involved. Every 60 seconds, that in a minute, 2 kilobytes of data that it can be sent 100 meters away by means of the power generated by simply knocking the desk with your fingers. See, this is of course, physically you will have to be present over there for the knocking purposes. But say these piezoelectric crystals are there, other than the thermoelectric power generation elements are there, which by themselves they can take care of themselves to produce the energy needed for these particular sensors. Now, for piping systems, another example it's given over here. For piping systems, energy harvesting can be done on the basis of temperature difference. When the piping it's you're running over a few kilometers like this, there will be a temperature difference, and the temperature difference of 60 degrees Celsius, it will develop. It has been said that the temperature difference of 60 degrees Celsius, it will develop 0.25 watts of power in this particular millimeter of energy harvesting materials. There are, not each and every of the materials, they are energy harvesters. So energy harvesting materials are there. If you employ those kind of energy harvesting materials, and if there is a temperature difference of like this, you'll be able to develop a power up like this, so that it can power the power constant sensor nodes. Now, access network technologies. How that the wireless sensor network is there, they are to be accessed. So, how to access these networks? The access network range is from a few meters to say 1 kilometers also. It includes all the devices between the backbone network and the user terminals. Achha. Because the wireless channels, they are open, very much open, and several channels are operating in the vicinity of each other. So that obviously, as some time ago I told you, there may be some conflict which may happen in time, in space, or in the frequency domain. When a channel is shared among multiple users, say a particular channel it is used by multiple users, so that conflict may happen in time domain, in space domain, or frequency domain also. Thus, the function of the access network technology is to manage and coordinate the use of certain resources to ensure the interconnection and the communication between multiple users which are sharing the same channel. Now, the access networks are your wireless LAN, then wireless MAN, uh, wireless metropolitan area network, then wireless personal area network or WPAN, and W1, that means wireless wide area network. Now, it's access network technologies, it's being continued, and you see these access technologies which are mostly used in various WSN technologies. These are like this. This Bluetooth 4.0, it is oriented towards medical WSNs. So in medical lines, if you apply this wireless sensor networks, mostly we use the Bluetooth 4.0. And in industrial WSNs, where your sensing and control it is your done, it is a particular standard, IEEE 802.15.4 E, small e. This particular standard it is used in industrial domain of WSN applications. And in IoT, it is your IEEE 802.11. Now, topology means your how the these nodes are connected between themselves, the manner in which the nodes are connected between themselves. That's called a topology. The network is connected. We have the wireless sensor network, which is connected to the internet via a gateway. So that the gateway, as far as this side, node side is concerned, gateway it acts as the sink, and from the gateway, it is transmitted to your internet. Process of forming a WSN. How the WSN or the wireless sensor network it is formed. See, sensor network nodes, they broadcast their status to the surroundings. Okay? And they receive the status from the other nodes to detect each other. That means this is how the process of forming a particular wireless sensor networks in the first place. Secondly, the sensor network nodes are organized into a connected network according to a certain topology. So that as your sensors have been placed, you know better at which places your sensors are to be placed. So that as far as as for that one placement of the sensors, you are the final authority of placing the wireless sensors. So on that one, the different topology which is to be applied for that one, it may be your linear, it may be your star fashion, it may be your tree topology, or it may be your mesh one. Although out of these four, the mesh topology that which is used your in most of the cases because of its because of its more advantages compared to the other ones. Finally, suitable paths are computed on the constructed network for transmitting the sense data. Acha. See, the power of a sensor network nodes, this is usually provided for by the batteries, so the transmission distance of the WSN nodes should be short because it's quite obvious that if the transmission distance increases, no, then in that particular cases, the more power will be needed, more energy will be needed to transmit a particular data for more distance. The transmission distance it can be your 800 meters to 1 kilometers in the open road and in environment with your line of sight. If line of sight it cannot be adhered to, then even in the your open or outdoor environment, this particular distance it will drastically come down. And see, this is the one. It will sharply decline in cases of a sheltered indoor environment to an estimated few meters. See, in the open environment where no obstruction is there, in that particular case, the transmission to the extent of 1 kilometer can be done between the two nodes. But when it comes to your some environment which is your indoors, which is your in the city where so many obstructions are there, in that particular case, the two nodes which in the open case it can be placed almost a 1 kilometers away between the distance between two nodes. It can be your 1 kilometers away. It cannot be that much. It will be a few meters only, and will have to your place two sensors a few meters. Away from each other to derive the best out of this networking technology. Acha. Uh, Now nodes act as both transmitter and the receiver. Obviously, a particular node sometimes it acts as the transmitter and sometimes it acts as the receiver. The first sensor node, this is the source node. It sends its data to the nearby node for transmission to the gateway. This is how it's occurring. The nearby node to which the first node it has delivered its data. This particular node it forwards the data to one of its nearby nodes, which is in the path towards the gateway. So that way the forwarding is repeated until the data arrives at the gateway. That is the destination point or the sync point. The protocols and some implementation techniques of WSNs can be adapted to manage the architecture and the technologies of wireless and wired computer networks. However, the features of WSNs are self-organization, self-adaptations, limited load energy, and unstable transmission links. These are some of the features. See, these are the various topologies in which WSNs can be connected. The network in your wireless systems can be connected in the star fashion. It can be connected in the tree fashion. These are the examples of your base topologies, which are mostly used in your wireless sensor networks. This is another way of your depicting the same thing. The star one, which has been shown in the earlier slide, these are the source nodes, and this is the sink node. The tree topology, these are the your source nodes. This is a can be it is your delivered. These are the first hops. This is the second hop. Then it is your delivered to the sink node. And this is the chain WSN topology 1, 2, 3, 4, and from the 4 it is being your advanced towards the sink. Classification of wireless sensor networks. So, say these wireless sensor networks, the particular topology that you are going to use in a particular situation, it all depends on your needs. What are your needs? Where you want to place your particular nodes to form your wireless sensor network? It is you are the final authority. You are the judge of placing the sensors in a particular fashion on which the particular topology that you are going to apply in your particular case. It all depends on that one. So the topology is totally or extremely application specific, right? Thus, they are deployed according to the requirements of the specific applications that you have in your mind. And the characteristics of one WSN, maybe it is different from the other WSNs. Anyway, irrespective of the applications, there is a classifications in which the WSNs can be classified. They can be classified in so many fashions like this. They can be classified, say static and mobile WSNs, then deterministic and non-deterministic WSNs, single base stations, multi-base stations, static base stations and mobile base stations, single hop and multi-hop WSNs, then self-reconfigurable and non-self-configurable WSNs, and homogeneous and heterogeneous WSNs. So, what is your static and mobile WSNs? In static networks, all the sensor nodes are your static. So, but uh, these particular networks are not your much of your use because sensor nodes they are in most of the cases they are mobile in nature. That is your some applications, especially in biological systems, require mobile sensor nodes. So an example, it's a very common example is to track an animal. It's moving. Animal is moving. Sometimes it is resting at a particular place. So that monitoring or tracking of that particular animal is to be done. Like your number of animals in a particular place, they are to be tracked. So that it is falling under the purview of your mobile WSN. Now, deterministic and non-deterministic WSNs. In a deterministic WSN, the position of a sensor node it is calculated and is made fixed. This predefined deployment of sensor node is possible in only a limited number of applications. And that means it is pointing to the fact that WSN technology is mostly non-deterministic in nature. For non-deterministic networks, WSN networks, they require a complex control system for their operations to be achieved. Now, single base station and multi-base stations. In a single base station, that means there is a single step and only one of is doing the business. So that when we have a single base station, it does mean that the physical dimension of that particular wireless sensor network it's very limited. It's a small one. It's located close to the so and this single base station. That means this base station. That means it is the sink. Stressing upon that the base station is the sink in which The sensors output data, they are being delivered in a single hop to this particular sink or the base station. It is located close to the sensor node region, and all the sensors communicate with these particular base stations. Individually. For a multi-base station WSN, more than one base station is used, and a sensor node can transfer its data to the closest base station with which the sensor node can identify itself. Now, base stations can be on static, base stations can be on mobile. Uh, Even base stations can be either static or mobile. The static base station has a fixed position, usually close to the sensing region, right? And mobile base stations, it moves around the sensing region, and it should be seen that load on the sensor nodes it is equitably distributed, or it should be on load on the sensors that should be balanced. Single off or multi off, which already explained to you. In a single off WSN, the sensor nodes are delivering the data to the sync straightway. But in case of your multi-hop, this is your from the peer nodes and the cluster heads are used to relay the data so that energy consumption is reduced. In case of your geographically, wide area, if suppose that instead of your multi-hop, you use the single hop single hop technology for your delivering of the data to the sync or the base stations. In that particular case, a particular sensor will have to cover a huge distance for getting into the this particular what's that called your sync. But as your distance increases, amount of energy consumption it also increases quite a lot. So that it doesn't make sense for a geographically wide area to have a single hop WSN. And that is why that has given rise to a multi-hop WSN in which the outer periphery, the particular nodes which are far off from the sync station, they deliver their output data to the particular layer in which the nodes are in a way closer to the your sync. Then again they deliver their data to the next one, which are even more closer to the sync, and that way that it progresses until and unless all the data from all the sensor nodes they are collected by means of this multi-hopping technique and ultimately delivered to the your this sync. Then self-reconfigurable and non-self-reconfigurable WSNs. In self-reconfigurable WSNs, the nodes are able to organize themselves and maintain their connections, and they work collaboratively with other sensor nodes to accomplish the task of this WSN. In the other category of this particular one, the sensor nodes, they cannot organize themselves in a network, and that means they rely for their operation on a control unit to collect the information from these particular individual nodes. Homogeneous and heterogeneous WSNs. In homogeneous net, a particular WSN, it can be termed as a homogeneous. It is homogeneous in nature. If the sensor nodes have similar energy consumptions, they have their computational powers likewise, and they are having your more or less equal storage capabilities, then it is called a WSN, which is homogeneous in nature. If it is otherwise, that some of the sensors they are having higher computational powers, some of the nodes are having much more your energy consumption compared to the others. In that particular case, that particular WSN falls on the category of heterogeneous WSN. Uh, Now, position of WSN nodes, they are your random in nature. We are now, coming to the case of your self-organizing mesh technology. And so now coming to this particular place, a smart mesh ad hoc networking technology. In this case, what happens is a node first monitors the neighboring nodes and measures the signal strength. A particular node it monitors some node which is its neighbor, and it measures the signal strength. Then it selects the appropriate neighbor node for time synchronization. Which one is which this particular node it is selecting? The one that which is having the most strength, with which it will try to identify itself with the neighbor node. It is identifying itself for time synchronization, and then it sends a join request. Then the neighbor node it forwards this request to the gateway, and this way the gateway receives the request and assigns network resources to that particular node which started these deliberations in the first place. Based on this mesh network, the sensor node network nodes can be assigned with your two or more than two transmission paths to improve the reliability of the network. That means a particular network can be assigned not one but more than one your network paths for it to deliver ultimately to the sink its data. So time synchronized mesh protocols, which is called your TSMP, they can support your self-organizing networks. They are self-supporting in nature and maintain a network consisting of, many nodes. Now, dumb nodes in stationary WSN. So that the concept of dumb nodes, it is now being introduced and it is applicable in the case of your stationary WSNs. So that HOD in a few minutes back time, it uh, told that because of the cloudiness of the sky around this particular place, the network connectivity sometimes it decreases. So here also we are, falling back upon the environmental issues of say certain time the environment is it is very sunny place, and sometimes it is your raining and it is your cloudy or foggy weather. So that gives rise to a particular node, which in a particular case it is working nicely. And but if the environmental case or the surrounding that it becomes quite foggy in nature, then a particular healthy node it becomes your dumb. So what a dumb node is, in this particular node it can sense its surroundings but cannot communicate with its neighbors. Why there's a particular distance between this particular node and to the particular node to which it wants to communicate, and up till now it communicated nicely when the environment was very sunny in nature. This shrinkage in communication range, that means there is a shrinkage in communication range, and so that the neighbor node is outside this communication range. So why this shrinking has taken place? This is attributed to environmental effects, like it's written in some pages. Back to this. These environmental issues are your temperature, then fog, then rainy seasons, and like this. But if the, this environmental law, if this environment, if it improves, say it's raining cats and dogs now, and after some time the sky becomes crystal clear. In that particular case, while it was raining, the particular healthy node, it, went into the dumb mode so that it cannot communicate because of shrinkage in communication range. But when the sun shines again after the rain is over, and it is very much sunny in nature outside, that particular dumb node it will come out of its dumbness, and it will behave in a normal fashion, so that if it has some data to be delivered to its neighbor node, it will be able to deliver the data, because the shrinkage in communication range which took place during the I mean uh, very bad weather situations, it improved now and it is back to the particular one in which it was there. So that a dumb node, it is dynamic in nature. So that a node, it may be, in conclusion, we can, infer it in this particular fashion that a healthy node or a particular node which is communicating with its neighbors now, it can fail to communicate, in future, if some environmental issues are there. If it rains, if it is foggy, then it will become dumb. And when the weather improves, when the sun shines, when the weather is very, very crystal clear, then it will come out of its dumbness and it will behave as it was behaving previously, so that it will become a healthy node again. So dumb node behavior it results, so that you see when the node becomes a dumb one, you see it is in the circuit, it is consuming the power, it is but that particular power it is becoming a wastage. Why it is a wastage? Because it cannot communicate. It cannot communicate. But it cannot accept any data. So that my power it is going down because of its working. But because of the dumb behavior of that particular node, it can neither send nor it can receive any data from the outside world, from the neighboring nodes, and that is why it is a simple wastage of power, and it reduces the lifetime of the network. So performance of a WSN it is affected by denial of services. That means attacks, misbehavior, the denial of services attacks. These are your by means of your data poachers who are trying to do some injustice to your system. Those are called your data poachers. Misbehavior, faulty nodes, and these environmental issues. That is your dumb behavior. These are the some of the ones on which performance of a WSN it depends, and it is degraded if anyone amongst them are present in a particular WSN. So connectivity, see, starting from this place, connectivity is lost between the sensor nodes, and one or more sensors may get isolated. So that because a WSN node it is your energy constraint, it's important to activate certain number of intermediate nodes in the particular places at which the dumb nodes are there, so that the connectivity that is lost between the nodes can be re-established. But by doing so, because of the energizing of certain extra nodes, this increase the energy consumption. A faulty sensor node may not cover its sensing area, create congestion in the network, and like this. Acha. As environmental effects are time varying, a dumb node will come out of its dumbness. I have already explained to this. Now, a dead node. A node can become your dead. In that case, it can neither sense nor communicate. It is, not. It is not like your this dumb node. Acha. Now, selfish behavior versus dumb behavior. And why we are going to term some behavior of a node as your selfish. A node becomes your selfish when it conserves its own resources. Resources means I am talking about your power resources, which is at a premium. During the time that a node becomes selfish, in which case it will not forward data that it received from from its neighbors, but it is able to transmit its own data, its own sense data to the neighboring node. That means a node becomes selfish, in which case it will not put forward data that it has received from other neighboring nodes, but it can transmit its own sense data to the neighboring nodes. So by doing this, it can conserve certain amount of your this what is called your power for the energy that it can save upon that one. But it is going to lead us to nowhere because it is unable to transmit the data that it has received from the neighboring nodes. So that although by becoming the selfish, it is able to conserve some amount of power, uh, but it is not a healthy situation as far as your efficiency of the this particular WSN is concerned. Now, a selfish node can save its power by dropping the packets received from other nodes. But in the case of your dumb behavior, a node is able to neither send nor receive any packet. because of secret in communication node. But though it consumes power, it does not provide any service to the network. When it becomes your dump, so that it neither can receive nor your this provide any service. It cannot receive anything, receive any data, or it cannot transmit any data. But by being your active, it consumes the power so that unnecessarily the power is going down without and also at the same time it is degrading its performance or degrading the performance of the WSN also. Dead node versus dumb node. Dead node means your a node becomes your dead, in which case it can neither transmit nor sense data, as both its sensing and transmitting units had become deactivated due to some disaster, due to some fault, or due to because of the worn out battery. Battery has come down to a certain extent that it cannot, accept anything. The node can accept anything. The node can neither transmit anything. That means if some disaster happens to that particular node, something which is not related to your battery power, or else the battery power has gone down to the extent that it can neither sense nor send the receive data to certain neighboring nodes, then it becomes your dead. So the dead nodes, they stop working permanently. They work. They will stay over there, and but they will not work at all for the duration for which the rest of the network will be in operation. So that these particular dead nodes, they cannot be considered anymore for sensing or transmitting any data in the network. Therefore, any protocol designed for use in these networks should avoid these nodes. These nodes mean these dead nodes. The WSNs, the protocol should be such that if certain dead nodes, obviously there will be situations in which certain dead nodes will be there in certain WSNs. So that the protocol should be designed in a certain particular fashion, in which case we can just bypass the dead nodes and still we can enjoy the connectivity of this WSN. And dumb behavior, it is dynamic in nature, wherein a node starts behaving normally when the weather improves. The low energy node versus dumb node. Anyway, dumb node the discussions have already been taken place. So low energy node. Why a node becomes a low energy? Because of its continuous use, day in and day out. Battery power is it is being depleted, and for a particular node to transmit data to its neighboring node, we need to have some threshold level of energy. The battery power will need to have some threshold of energy. It will be, above this particular threshold of energy level, so that it can transmit some data to its neighbor node. But because of continuous usage of the battery, if that battery power, comes down below that particular threshold, in that particular case, a sensor node uh, becomes a low energy node, and it can neither, receive nor or send any data to the outside world to its neighbors. Achha. Now, not much of anything to be told in this particular slide, so that I'm just moving over. So, not this is a normal wireless sensor networks. See, certain nodes they are your circular in nature. Certain nodes which are your what is rectangular or square in nature. So this circular ones, they are your active in nature, so that so many nodes are there. If at any given instant of time in future, this suppose this particular node, which is sleeping node at the present, it is connected to the network, then it will become your active node, and its symbol will be changed from your square ones to that one circular one. Now, as far as your dumbness is concerned, uh, as far as your dumbness is concerned, these are the nodes, these are the active nodes, they are connected in this particular fashion, and these are your solid lines, so that means these are the normally connected nodes. And in this particular case, I mean, apart from your solid lines, there are your dotted lines also. The dotted lines means your connection as of the present moment between this particular node and that particular node. It is not there. So there are also certain ones which are you're not connected at present. So the number of nodes which are connected, they have been shown by the solid lines, and the ones which are not connected, although physically present, they are shown by the dotted ones. So now disconnected group of nodes. You see, this is a group of nodes encircled like this. This is another group of nodes. This is another group of nodes. See, this is a junction A. Junction and this group of nodes output lines. These output lines from this group of nodes. These are your dotted. Like this one and this one. This is your dotted. And from this group of nodes, only a single connection is there with A, which is a dotted. So that what is your can be concluded, what can be inferred about this disconnected group of nodes is that although physically they are there, these so many nodes are present, but none of them are connected to this particular node A, because all the lines which are emanating from A and going to the other nodes, they are dotted in nature, and so that the whole thing it is 100% disconnected group of nodes, and it is also a fully disconnected nodes like this, because all these lines that have been shown, they are your what's that called? They are your dotted in nature. Now, WSN architectures, these are your layered architecture and clustered architecture. The one that which is on the left, it is a layered one, and on the one on the right, it is a clustered architecture. So that you see, this is a particular layer. This is another layer. We are turning it. This particular one, red ones. This is the layer one. That means they are. Residing in close proximity to the base station. To the this is base station of the sink. This is the layer one, and we are proceeding outside, proceeding away from the base station, so that this is the middle layer, this is the layer 2, and this is the outermost peripheral layers. This is called your layer 3. And in the clustered architectures, you see these, particular one, these are the 3 nodes. Uh, these are under this particular cluster, and this is the cluster head. This one is the cluster head. In this particular one, these are individual sensors, and this is the cluster head. That means it is clustering, it is accepting the data from this particular 3 nodes, and it is clustering the particular data which is being connected to the base stations like this one and like this one also. This is also the left one, this layered architecture. This is another figure of this one. Uh, see, this particular the outermost peripheral layer. This is the third layer. The first layer, which is very close proximity to the base station. This is the layer one. Beyond this one, this is the second layer, and beyond this one, this is the third layer, which is on the right side of this particular dotted one. So, what is a particular layer? This is the definition of a layer. A layer is a set of nodes. A layer is a set of nodes having the same number of hop counts to the base station. So that 2 nodes, they will be, falling in a particular layer. We can claim 2 nodes to belong to a particular layer, say layer 2 or layer 3. If the number of hops by which it can deliver its data to the base station, it is identical for either of them. Clustered network architecture, some details about this one. Based on low energy, this clustered one, this is, based on certain principles, which is called your LEACH, low energy adaptive clustering architecture. Uses a two-tier hierarchy clustering architecture. It can be on, more than 2 tier also. The ultimate cluster head nodes, they operate in a TDMA or time division multiplexing scheme schedules. The nodes that they are transmitting the data as per the assigned slots assigned by the TDMA schedules. And the energy efficiency of the leech is mainly that means it is pointing to the fact that leech is having a high energy because of the data fusion that takes place before any data that is being sent to the sink. Now, bridging the IP network with the WSN's network. Now, WSN, it uses the internal addressing scheme. WSN, when it is used, it uses its internal addressing scheme, which is limited in nature. This address length is relatively short and suitable for implementing in low-powered embedded sensor network nodes. However, this internal address management method, it is incompatible. It is not incompatible with the IP method of addressing, which is used in our internet system. So that there should be some linking between this wireless network system and wireless sensor network nodes and the IP network nodes. There should be some linkage, there should be some interaction so that this difficulty in interacting between the two systems is overcome. Thus, there is a need to resolve the connectivity problem between WSN network and the IP network. See, this traditional IPv4, this version 4 of the IP, the addresses as your, I mean, so many IoT devices are coming up. The maximum IPv4 address capability is getting gradually depleted and depleted. So that instead of IPv4, IPv6, that means IP version 6 technology, which is having an enormous address resource, this is being increasingly being used in WSN networks. As a result, 6 low band, low power wireless technology based IPv6 has emerged. 6 low band, it is generally implemented in a simplified IPv6 manner. So that IPv6 protocol, it's having certain protocol, it's simplified as far as it is connected in a WSN network. It is simplified and then connected. Achha. So, see, header compression and packet fragmentation, it takes place and reloading is implemented by adding an adaptive layer in between the IP layer and the link layer. Between the vessel layers, this IP layer and after, below that one, the link layer is there. So that to bridge the gap between this WSN networks and the IP networks, an additional layer, which is called your adaptive layer, it is your inserted so that the bridging of these two networking technologies, this IP layer and this what is that called, WSN networks, they can be done. So that by doing so, by this insertion of these adaptive layers between the IP layer and the link layer, it ensures seamless and reliable interconnectivity between these two networks. One is sensor network, another is your IP network. This flow control, HOD madam, there is still some time left. HOD?
Hello, sir.
Hello?
Hello? Hello? Hi, sir.
Is there certain certain time is left? No, I can continue for some 15 minutes or 20 minutes more.
Okay, sir.
Is it?
Okay.
Okay, right.
Okay.
Right. So flow control in WSNs. So there is a flow control in normal systems, that which is called your traditional systems or your wired systems. You see the traditional network or the stable wired network systems, and data will be lost due to congestion. So that between the sensor and the receivers, data loss takes place if sending rate is more than the rate at which data can be accepted by the network in which it is a traditional one or the wired network. If that takes place, then flow control is affected by adjusting this sending traffic. That means adjusting the sending traffic means by your lowering down the number of bits that are being sent to the receivers. That is what you're adjusting the sending traffic according to the data flow rate. In this case, when data loss occurs, sender decreases transmission rate, and when data is not lost, transmission rate is your increased, so that in lesser amount of time, data transmission can be affected and be complete. This is not the case with your WSNs, in which such flow controls cannot be applied. If we apply this, then only the efficiency of the network will go down without being able to solve the problem. In this particular case of WSNs, the technology that which is your used, this is called your adaptive flow control, which checks the reasons for packet loss. Something has been said, and the receiver it has let me know that the packet has been lost. So that there are certain ways of ascertaining whether certain packet loss has taken place, and as per that one, the flow control is adjusted. This is called your adaptive flow control, which is your taken which is taken recourse to with your WSN technology. Now, data aggregation in WSNs. Data aggregations means your data. So many sensor nodes are there. The proximity of two sensors give rise to the fact that the output from the two sensors are much alike. So that in WSNs with high coverage means your the nodes are placed in the very close proximity with each other. That means two nodes are very close to each other. The neighboring nodes will have, in that particular case, the neighboring nodes will have some, some degree of redundancy will be there. That means some duplicacy of data is there. So that suppose the two nodes, each of them, they are, outputting 100 bytes of data. That means 200 bytes of data from the two neighboring nodes. But because of the degree of redundancy it is there, we can set off certain amount of duplicate data, so that the final one that which can be sent to the sync side, it may be brought down to your 125 bits or 135 bits instead of 200 bits, which we have obtained from two nodes, neighboring nodes. So that gives rise to your data aggregation. So that what data aggregation is, it is the process of integrating multiple copies of information into one copy. So that instead of sending each and every of the copies to the one, and remembering that, as more and more of transmission takes place, more and more of your energy is consumed from the battery constraint or energy constraint these WSN networks. So that the less the amount of your information that is to be sent to the your sync, that is better for the energy stuffed, energy constraint network. That is why data aggregation is takes place. That means data from certain neighboring nodes, they are your aggregated, they are assorted, and they are your done in such a fashion, so that total number of bytes, that is your reduced much, and this reduced amount of data, without losing much of its your functionality or much of its information, it is being transmitted transmitted onwards towards the sync side. Acha. Uh, Monitoring data of the same object requires the collaborative work of multiple sensors, which are there in the close proximity. It improves the accuracy and reliability of the information obtained. Acha. Then, in the data transfer process, looking for aggregating nodes, data aggregation operations, and for the arrival of data from the other nodes, it increases the average latency. This is the flip side or the negative side of data aggregation. It increases to certain extent the latency of the system. If the situation in which you are working, you can bear, you can absorb this latency, amount of latency, because of the data aggregation process, then it is advisable that data aggregation should be done, because data aggregation, by virtue of its assortment, it takes some time. but it leads to, some kind of latency in the total network systems. Now, some security aspect that it is being discussed in traditional TCP/IP networks. The security that is built, it is built on your confidentiality, integrity, and availability of network data. Whereas in WSN networks, it requires apart from this traditional security of your confidentiality, integrity, and availability, there are the need of certain things which are in extra in nature. This is trust, this is security, and this is privacy. This is called your TSP. So that in situations of your WSNs in which TSP is added up, TSP is prevalent, TSP is your applied. That is called your TSP WSNs, trust, security, and privacy WSNs. So they may, depending on the application scenario, require security protection of confidentiality, integrity, availability, non-repudiation, and user privacy. So that TSP WSNs may need to protect the nodes against tampering done by some outside agencies. Protect the communication channels. That means here also the communication channel is also to certain extent vulnerable as far as the data hackers or the data poachers are concerned. And also the routing and network layer, uh, it should be the TSP WSN network should be such that the data hackers cannot touch the network layer also when the routing the network layer takes place. The technology of TSP WSNs consists of message authentication, message encryption, access control, ID verification, ID authentication, etc. like this. Now this is a figure of the TSP architecture for the WSNs. This encryption, it is corresponding to your hardware layer. Is access control and the key management, it is your operating systems. Secure routing, it is obviously in the middle where layer. And secure data aggregation. Data aggregation is being done in the application layer. And this is some of the network attacks, different types of network attacks that can take place in the network in which the WSN is working. These are termed as your wormhole, DDoS, jamming, sinkholes, civil attacks like this, and other security features are auditing, intrusion, detection, privacy, etc. So now, node security and sleep deprivation. See, each and every of the nodes, they yours should be secured. They, on these are your these power constant networks, WSN networks, these nodes in the WSNs. They are your very much vulnerable to your the outside agencies, the data hackers. That means they can be tampered with by some physical attacks. Physical attack means by virtue of being present over there and doing some, malfunctioning in the systems. That can be done without authorizations from the, WSN's authority. So, node security may contain. That means each and the. It is boiling down to the fact that each and every of the nodes, they should be secured in nature. So that when it is your a particular node, it is your sending some information. It is in the wake up condition, and rest of the same time that it should be put into the sleep mode. So a special class of denial of service attacks. There is a class of service attacks which is called your special class of denial of service attacks. This is called sleep deprivation attacks. That means a particular node which is sleeping, it's not allowed to sleep, so that it is remaining awake for the duration of the time at which it is not sending or receiving any data from the neighboring nodes. So that because it is not sleeping, it is in the awake condition, it is consuming the standard battery power. So that battery resource, battery energy, it is, firstly, getting depleted. And this is how data instead of your data hacking, it is your by means of your certain your ones. which is your denial of sleep to the particular nodes which should be in the sleep condition as of the present moment, that is being denied by the external agencies. And by doing so, the battery power, it is your firstly depleted, and it is so that either the battery has to be replaced, or that particular node, because of its constraint of energy, because it cannot have any energy in its battery, it becomes a dead one as far as that particular time is concerned. So it reduces the lifetime of an attack sensor node. If sleep deprivation attack is taking place on a particular node, its lifetime is severely hampered and it is reduced. So standard security mechanisms, it cannot, ward off these particular attacks. Now, so what is the way out of this? You see, this is the main radio, by virtue of which it can, send it to the sync, or from the sync side, it can, accept some, information within this one. This particular, one, you see, there is another one which is a inserted into this one, which is called your wake up radio. So during the time this, this particular sensor dot, this is the symbol of the sensor dot, that it is, obviously it is some time at which it is your active. Say suppose at this time it is your sending the, data to the same side. So rest of the time, the sensor node should be, forced into the sleep mode, but because of that particular one sleep deprivation attack, it may be that it is not allowed to, sleep at the particular time. It is expected to sleep. So what is done is, in this particular sensor node, another block is inserted, which is called your wake up radio. This wake up radio, it listens onto the channel when the sensor node is in the sleep state, so that the point is, this wake up radio, it is listening to the channel, this particular channel, when the sensor node is in the sleep mode. And what is peculiarity about this wake up radio? It remains in the wake up condition. It is a very, very ultra low power one. So that although it is remaining awake, this wake up radio, it remains awake all the time, because of its ultra low power consumption. So battery power doesn't reduce at the particular rate at which, if in case the sleep deprivation attack takes place. So that instead of to ward off this sleep deprivation attack, this wake up radio is inserted into this particular sensor block, and which consumes a very ultra low power consumption. It takes place, and what does it do is, it, that means this wake up radio, it triggers the sensor wake up when it receives a wake up signal. When it wakes, a wake up signal is received by the wake up radio, it energizes the main radio, that either it is to send data or it is to receive the data. It does it with business, and it is forced into the sleep state, and then in the sleep state, the wake up radio then takes over. Crypto algorithm is your some special classes of algorithm in which the original data of the sensor node, it is your changed or encrypted, so that what data I am sending to you is because of encryption. AES 128 algorithm. This is an encryption algorithm, by virtue of which, even if some data poachers can have its hand into this one, it can get the data, but it's an encrypted data, so that he cannot decrypt this particular one, so that it is safe. So that way the crypto algorithms are your there. But in case of your this WSX, in these particular cases, some special encryption libraries are there, who have developed certain special encrypted algorithms, specially earmarked for your WSNs, which can be applied at the applications layer, network layer, and the data link layer also. So key management, there are certain keys, not going to the details of the there. It is key management is done in the area of your security of your WSNs. There are different key management schemes are there, like global key management, random key management, location key management, clustering key management, etc. And there are certain ways by virtue of which the security by employing the keys, different keys at different levels can be achieved. Then it is secure routing. When routing is taking place, uh, it is vulnerable to the data poachers, so that they are to be secured. So for WSNs also, there are some secure routing. They have been designed for security of WSNs when routing is taking place. So this is your secure data aggregation of WSNs. Secure data aggregation of WSNs is that several data from your neighboring nodes, they are your aggregated, and then it is your secured. This data is your secured and then transmitted to the higher aggregation nodes. To these higher aggregation nodes, they judge the credibility of data. That means whether the data that this higher node has received just now, whether this data is credible in nature or not. And then it does its aggregation calculations based on redundancy. Each aggregation node selects the next safe and reliable hop, transmits the data to the central node. The central node judges the credibility of data and do the final aggregation calculations. Initially, data aggregation regarded energy as the object, but barely considered the security issues along with this. But now, secure data aggregation is putting the most, importance to your secure data aggregation. Without much considerations on the energy issues. So that's thank you to all for the present hearing for almost close to your 2 hours. This is huge applaud and thanks to all the participants from my side. Thank you. Any questions from your side?
Hello, participants.
Hello, participants. Yes. HOD, you
Any
are speaking.
any question? If you have any query, you can unmute yourself and you can interact with the
Sir,
resource
I have
person.
one question.
Yes, sir.
Sir, you have seen that from energy efficiency point of view, cluster-based communication is better compared to the layered architecture, I think. But
Energy, as
from
far as
energy efficiency or power efficiency point of view, sir, which one is better, cluster-based architecture or layered-based architecture?
clustered architecture and the layered architecture. I mean, I mean, as far as I know, when I was discussing this layered architecture and the clustered architecture, I was not, not pointing to your energy efficiencies of these two as far as the difference between these two architectures are concerned. The point of these two architectures is that the placement of the nodes, because the nodes are strewn all over the places. No, in certain particular cases, it is the layered architecture which is of which gives your more advantage to the particular ones who design this WSN structure. And in certain particular cases, it is your in the clustered form. I mean, in groups of certain nodes, they are clustered in certain cluster. From that particular cluster to the next cluster, and then to the cluster which is more in proximity to the your sink. That way, it is your delivered to the final sink or the gateway. So, here I suppose that I did not, discussed anything vis-a-vis your energy efficiency as far as these two,
No, sir, it is my actually
architectures are concerned.
question. Sir, actually, it is my question from power efficiency point of view, which one is better? It is actually my question, sir. Okay, sir.
Okay, that will be your question.
Yes.
Again, I mean, I suppose that it cannot be answered in a digital fashion. As far as my knowledge goes, it cannot be answered in a digital fashion. So, I mean, either you will have to opt for this first one or the other one. Again, why you are going to opt for the first one, that is your layered architecture, or you are going to opt for the, I mean, clustered one. So it depends on the, I mean, physical existence or the physical placement of the, I mean, these particular nodes. So that way, the comparison most probably, as far as my knowledge goes, they cannot be compared that way, which is better.
Okay, sir.
Suppose that you got my point.
Yes, sir. Okay, sir.
Anything
Thank you,
else?
sir.
Thank you. Anything else?
Any question, participants, from your side?
Faculty members, the participants, if you have any questions, feel free to, I mean, ask questions to me.
Okay, sir, I think there is no more questions. So you can off the screen.
So can I mean, going for stop sharing?
Yes, sir. Yes, sir.
So I am clicking the button stop share, okay?
Okay, sir.
Can I go out of the system now? Can I leave? If
Thank you. Thank you very much, sir, for such informative session. Thank you very much. And I would like to request the organizing team to share the memento that we have prepared for sir. Sir, this is a very small token of appreciation and the respect from the
the
Department
virtual
of...
world.
Yes,
In
sir.
virtual world, I get this token of appreciation.
This is the this is the ultimate thing that we can do.
As the, I mean, pandemic is raging so much now, second wave is there. In the midst of that one, we have to, I mean, do our business and,
Yes,
I mean, pull on in life.
Yes, sir.
Thank you, HOD. Thank you, Dr. Banerjee, very much. Thank you, participants, very much.
Okay, thank you, sir.
So that I am just now leaving, okay? Right?
Okay, sir. Okay. Okay. So, okay, participants, now we are ending our session. Tomorrow from 11, we will start. I will share the link 15 minutes before the program. So, keep watch in the WhatsApp group. Okay. So, any more questions? Otherwise, I will end my session.
This link, please.
Quiz link has already been shared, sir, and it will be shared in the WhatsApp group. It has already shared in the WhatsApp group also.
Thank you, madam.
Okay. Okay, so I am ending my session. Thank you all. See you tomorrow. Thank you.